Imagine a world so violent, so relentlessly hostile, that every passing hour brought explosions greater than any volcanic eruption seen in human history. A world where oceans boiled away into steam, continents melted like candle wax, and the sky itself glowed red with the heat of falling fire. This was not a distant exoplanet. This was Earth. And yet, from this nightmare landscape, something extraordinary emerged: life. I'm Alex McColgan, and you're watching Astrum. Join me today as we peel back the crust of time and uncover the astonishing truth about how the deadliest era our planet ever faced may have been the reason life exists at all. To understand this paradox, we must travel back more than 4 billion years to an Earth that looked nothing like the blue marble we know today. Picture a scorching ball of molten rock, wrapped in a suffocating haze of methane, ammonia, and volcanic smog. Water was scarce, continents non-existent, and meteorites still zipped through the solar system like shrapnel left behind from planetary formation. At first, these collisions happened often, but gradually decreased, as you might expect. But then, long after the planets had stabilized, a sudden surge of impacts struck the inner solar system, a mysterious and catastrophic chapter we now call the Late Heavy Bombardment. The Moon still carries the scars of that era, gigantic craters formed not across billions of years, but likely within a narrow burst of cosmic fury. Earth would have looked even worse, except our planet erased the evidence through volcanic resurfacing and constant tectonic motion. So what could have triggered such an unlikely storm of destruction long after the planets had formed? Surprisingly, the answer may lie not on Earth, but with a giant lurking farther out: Jupiter. Scientists believe that in the early solar system, Jupiter moved dramatically from one orbit to another, dragging countless asteroids along with it. These gravitational shifts tore apart ancient orbital paths and sent debris hurtling inward, straight toward Earth's fragile young surface. But incredibly, this chaos delivered something more valuable than destruction. It carried the raw ingredients of oceans, chemistry, and ultimately, life itself. To understand how devastation could become creation, we must look closely at the cargo inside those ancient asteroids. Not all of them were alike. Some, the stony S-type asteroids, carried metals like iron, nickel, and silicates, materials that would become essential components of Earth's crust. But others, the darker, older C-type asteroids, held something far more precious: water-locked in minerals and ice, and complex carbon molecules that Earth could not easily produce on its own. These objects formed far from the Sun, where temperatures were low enough for ice and organics to accumulate. When Jupiter migrated inward, and later outward again, the orbits of these primitive time capsules were disturbed. Millions of them began drifting toward the young Earth, colliding with unimaginable force. Each strike gouged enormous craters, melted entire regions of crust, and vaporized rock into clouds of molten droplets. The surface would have looked like a patchwork of fiery seas, glowing cracks, and volcanic plains, constantly reshaped by fresh impacts. And yet, inside those destructive collisions lay the seeds of transformation. When these asteroids shattered upon impact, they released water into Earth's atmosphere and surface. Early Earth could not hold on to water when it was molten, but by the time this bombardment occurred, the crust had cooled just enough for liquid water to remain. Oceans began to gather in low-lying basins, steam condensed into rainstorms that lasted thousands of years. The world's first seas were forming, dark, turbulent, and rich with dissolved minerals. But perhaps even more significant was the chemistry delivered by those asteroids. Meteorites contain amino acids, carbon chains, and phosphates, the fundamental building blocks of DNA and RNA. These fragile molecules had no chance of surviving modern atmospheric entry, but during the Late Heavy Bombardment, far larger asteroids, some hundreds of kilometers across, could protect these compounds from complete destruction. When they struck Earth, they mixed with volcanic gases, water vapor, and mineral-rich basins to produce a chemical environment unlike anything that exists today. In this roiling mixture of heat, lightning, pressure, and organic molecules, something extraordinary began to emerge. Life was not yet present, but its ingredients were assembling, waiting for the right moment. And that moment was approaching, hidden behind the last waves of cosmic destruction. As the bombardment gradually subsided, Earth continued transforming. Water pooled across enormous areas, covering much of the planet. Rainstorms persisted for millennia, cooling the crust and stabilizing the surface enough for oceans to deepen. Hydrothermal vents erupted along the ocean floor, pumping mineral-rich, energy-laden fluids into the seas. These underwater environments created natural chemical reactors, perfect incubators for primitive molecular systems. Meanwhile, Earth's crust was still young and restless. Tectonic plates shifted rapidly, breaking and reforming. Craters that might have preserved a record of the bombardment were swallowed by rising magma or recycled into the mantle. Unlike the Moon, which froze in time, Earth was constantly renewing itself. But even though the geological scars disappeared, the chemical legacy remained. Within Earth's oceans now existed water from distant reaches of the solar system, metals to build complex molecules, and carbon-based compounds that would become the scaffolding of biology. The timing could not have been more perfect. After hundreds of millions of years of catastrophic impacts, the bombardment finally eased. For the first time in Earth's history, conditions stabilized. The atmosphere cooled enough for sunlight to reach the surface. The oceans no longer evaporated instantly. And in this narrow window, something remarkable occurred. Chemistry found its rhythm. Scientists believe that the earliest self-replicating molecules appeared shortly after the bombardment ended. Fossil evidence and isotope studies reveal life emerging astonishingly quickly once the chaos subsided. It is as though Earth had been primed, loaded with the right ingredients and energized through intense planetary turmoil, and then allowed to settle just enough for those ingredients to interact in stable environments. Without the impacts, Earth would have remained dry or chemically barren, lacking the necessary components for life's spark. Without Jupiter's chaotic orbital dance, the asteroids might never have arrived. Without cooling at exactly the right time, oceans might never have formed. It's a chain of events so precise and improbable that it almost feels intentional, though it is simply the nature of cosmic physics playing out on a grand scale. Out of destruction came opportunity. Out of chaos came complexity. And out of a world torn apart by falling rock came the first whispers of biology. Today, nearly all physical evidence of this primordial chaos has vanished from Earth's surface. Plate tectonics, erosion, and volcanic resurfacing have erased any ancient craters. But the Moon remembers everything. Its airless, motionless surface acts as a geological time capsule, preserving the scars of impacts that Earth once shared. This is why scientists continued to return to lunar samples for answers. Radiometric dating of rocks collected by Apollo astronauts reveals a clustering of impact melt ages around 3.9 billion years ago, a clue pointing toward a concentrated bombardment rather than random impacts. But debate continues. Some researchers argue for a long tail of impacts gradually fading over time. Others believe in a sharp spike triggered by shifts in giant planet orbits. Future missions, like NASA's Artemis program, may help resolve these mysteries by collecting samples from unexplored lunar regions, giving us clearer insights into the solar system's violent youth. Yet regardless of the exact timeline, the implications are profound. Every ocean wave, every river valley, every raindrop on Earth ultimately derives from water delivered during this ancient storm. The metals we use in technology, nickel, gold, copper, were seeded into our crust by asteroid impacts. Even the carbon in every cell of every organism may trace its origin to a distant, icy rock flung inward by Jupiter billions of years ago. The asteroid era did not just shape Earth physically, it shaped Earth chemically, energetically, and biologically. It set in motion the processes that led to microbes, plants, animals, and eventually humans. Without that era of unimaginable destruction, Earth might still be nothing more than a sterile rock orbiting a star. So the next time you drink a glass of water, look at the Moon or simply breathe. Remember, You are connected to a storm of cosmic violence that once threatened to wipe Earth clean. That storm instead gave us oceans, minerals, atmosphere, and life itself. We were born from chaos, forged in fire, shaped by collisions that transformed disaster into possibility. Out of the deadliest era our world ever faced came the greatest miracle of all, a living planet.